Limits. Let's put down some numbers here. 1 divided by 0.1. That one equals 10. Okay, what about 2 divided by 0.1? That one equals 20. Okay. What about 1 divided by 0.001? That one equals, this was 10, and it's going to be 100, 1,000. This will be 1,000. And 2 divided by 0.001, okay, that's going to be 2,000. I'm going somewhere with this. Because if we keep on decreasing this number gets bigger and bigger and bigger. And we'll see that 1 divided by 0. See, I'm getting there. 0.1, 0.0001, 0.0001 will be like, a million or a billion, and then 1 divided by 0. And this, it's wrong to write equals infinity. First thing, because infinity is not a number, it is just a concept. And the reason why it's wrong is because we could do the same thing here, as 2 divided by 0 is also equal to infinity. And then if that is equal to infinity and that is equal to infinity, that means that these things must be equal. And then that makes it that 1 equals 2. So we've just kind of broken mathematics. So we do not write that. It is not right to write that, okay? So this is wrong things. What we can write is that we can write that the limit as x goes to 0, like what we're doing here, of 1 divided by x does equal infinity. That is true, okay? Not 1 divided by 0 equals infinity, but the limit as x approaches 0 equals infinity. And this is also equal to the limit as x approaches 0 of 2 divided by x, or 10, or 47. The problems we get with limits are like this. Solve this limit. 2x divided by x squared plus x as x goes to 0. So the first thing you can see here is you just kind of plug the number in. You see what happens. So if we plug in 0 in here, we're going to get 0 divided by 0 squared plus 0 is going to be 0. So we don't know. So there's two methods of solving limits. Okay, so the reason why we have limits is so we can approach something that we don't really know what's happening here. Here, we don't really know what's going to happen. Is it 0 divided by 0? So there's two methods of actually solving these limits. There's the smart way, and there's the, trial and error way. The smart way is to try to do some factoring. So if we have this limit here, limit of 2x divided by x squared plus x as x goes to 0, we could try to factor this. Okay, so all math still applies, is that we're just trying to put in x equals 0. So what can we factor here? Well, we can have 2x, and I can take out an x from downstairs, so I get x with x plus 1. And now we can see that we can cancel these two x here, and now we're going for the limit as x goes to 0 of just 2 over x plus 1. And now when we substitute 0 into here, we're going to get 2. And there's our answer. The second method, if you don't like factoring, is to just try to plug in numbers closer and closer, just like we are doing here. So we're trying to plug in as x goes to 0. This function, whatever this function may look like, it is going to something that we don't know. We know what the value is going to be 2, but let's say we're just doing method 2. So we don't know where it's going, but we know it's going somewhere. So what we're going to try is we're going to try from the negative side, and we're going to try from the positive side, and plug in numbers to see what happens. So we're again looking for the limit of x going to 0 of 2x over x squared plus x. And what we're going to do is we're going to just make up a little table here. Let's just try from the plus side. So I'm going to make a little table. It's getting a little tight here, but that's okay. So I'm going to plug in x values and y values. Y values will be the output of it. So let's try from the plus side here. Let's try the value of 1. Okay, so if you plug in 1 there, you're going to get 1. So 2, 1 squared plus 2 is going to be 1. The answer is going to be 1. So because it's 2 divided by 2. So I'll get 1. Okay, now if I plug in, let's go a little closer to 0. Let's try 0.1. Okay, And if I have 0.1, I can put that into my calculator. So I have 2 times 0.1 divided by bracket open 0.1 squared plus 0.1 bracket closed equals, I get 1.81. Okay, let's go a little closer. 0.001. And if you plug that one in, 2 times 0.001 divided by bracket open 0.001 squared plus 0.001 bracket closed equals, I get 1.998. And we can see it is approaching 2. Okay? And if you do this method, you should do it both sides because it might be approaching different things from different sides. So we're going to try it from the second side. So from the negative side, so 2x all over x squared plus x. So again, we'll make a little table of values, x and y, and we'll try negative 1. And if we put in negative 1 here, we're going to have, well, it's going to be negative 2 divided by negative 1 squared is 1, plus negative 1 is 0. Oh, we actually have like infinite there. It's going to be negative 2 over infinity. So it's going to be infinite. It's going to be a really big number. Okay, let's try something a little closer then. Negative 0.1. Okay. Now we're going to get 2 times negative 0.1 divided by bracket open 0.1 squared minus 0.1 bracket closed equals. And I get 2.22. Okay, and let's just try the last one here, 0.001. And we're going to put that in here. So 2 times negative 0.001 divided by bracket open 0.001 squared minus 0.001 bracket closed equals, 2.002. Okay, so they are both approaching the value of 2, and that would be the answer. Okay, so 2 different ways of doing it. One would be to factor and then just plug in the number. That's what we're trying to do. But if you plug in the number, you see you get 0 over 0. So if you factor, then you might be able to get an actual number out. The other way is just to take the original equation and just substitute numbers as you're getting closer to what your limit is doing. So we're trying for the limit as x goes to 0. So we're going to try from the plus side from here and from the negative side from here. And we'll see that they do approach the same thing.